We are interested in doing a research that can solve, problems and global challenges that can hopefully contribute to the United Nations Sustainable Goals. So one of the problems that we have, and I think it relates to us every day, is food waste. So according to the United Nations Food and Agriculture Organizations, there's roughly one third of food is wasted along the supply chain. So that's quite a significant amount of food. And when we go to our fridge, we look at our food packaging. There's different types of dates, and at the consumer level, sometimes misunderstanding of these dates can lead to food waste. So, for example, we will throw food past the best before date, or even before or close to. And on the other hand, when the food is not stored properly, the best before date or use by date is not really a good indicator, because the issue here is these dates are so static, it does not adapt to variable conditions. So understanding this challenge and knowing that how much food we have wasted, while on the other hand, there are certain regions or countries that do not have enough food for consumption. So we thought we can play a part a little bit by developing a technology, hopefully can solve this problem. So this is what exactly we are doing. So my team here at UNSW Chemical Engineering, we are developing colorimetric food sensors, which is an indicator that we can attach to food packaging, that can, so by monitoring the color changes, so typically blue to red, we can know whether the food is spoiled. So the colorimetric sensors we developed is based on polymers. So I'm sure we are familiar with polymers. Polymers are materials that almost exist in all everyday materials, like packaging, bottles, clothing. So what we do here is we have polymers with certain chemical groups that will react with the compounds produced during food spoilage. So, for example, when milk is contaminated with bacteria or when it is spoiled, it has a higher level of lactic acid. So what we do here is we design these polymers that have a chemical groups that will react specifically because of the changes of the lactic acid level. And once with the reaction occurs, it will change the conjugated backbone of these polymers, and then this leads to a changing on how the polymers absorb light. So then by eye, we see a color changes. So typically, the starting building blocks and the polymers come with blue color. So blue color will mean that your food is fresh. And then when it's purple, that will mean that we should consume it soon. And when it's red, that means it's already spoiled. So far, we have tested on milk. We are detecting the lactic acid in milk. We are also detecting, for example, if there is a toxin or bacterial contamination in milk. We tested on meat product. We also test on fruit ripening. So when fruit ripens, they will produce ethylene gas, and a similar principle with the detection of the ammonia gas. We design this polymer with chemical groups that will react specifically with the ethylene gas.